Imagine looking up at the night sky and realizing that something from another star system has just slipped into ours. Not a satellite, not a planet, but a stranger that doesn't belong here. For a brief moment, Earth was being watched by a visitor older than our sun, and we almost missed it. Tonight, we'll unravel the mystery of that interstellar wanderer, what it was, what it carried, and what its presence might mean for us. Before we begin, I'd love for you to join the journey. Drop a comment with where in the world you're watching from right now and what time it is where you are. And if you enjoy drifting off to these cosmic mysteries, remember to like the video and subscribe so you don't miss the next story from the stars. The ghostly discovery, how 3I Atlas first revealed itself. On a quiet night in 2024, far from the noise of cities and the warmth of streetlights, astronomers scanning the heavens caught sight of something almost too faint to notice. Just a pale speck of light, barely distinguishable from the background stars. At first glance, it seemed like nothing more than a stray flicker, the kind that telescopes routinely record and then discard. Yet within days, calculations revealed that this was no ordinary comet or asteroid. It was an object on a hyperbolic trajectory, a traveller not bound to our sun but merely passing through. That flicker, that almost forgotten ghost, was given a name: 3I Atlas, the third confirmed interstellar visitor ever observed. The story of its discovery carries a sense of wonder and fragility. Think of walking along a beach at night, waves rolling endlessly, and spotting the faint glimmer of driftwood floating far out in the water. You almost miss it, but if you catch it at just the right angle, you know you've seen something that doesn't belong. 3I Atlas was exactly that. Cosmic driftwood, carried from a storm in another star system, swept across the galactic tide and arriving unannounced on our shores. The telescope that found it was not searching for interstellar messengers. It was part of the Asteroid Terrestrial Impact Last Alert System, ATLAS, designed to scan the skies for potential threats to Earth. Its mission was planetary defense, watching for small, near-Earth objects that could cause damage if they ever slipped through unnoticed. Yet, in its careful sweep of the sky, ATLAS spotted something far more mysterious, a faint glow moving too quickly on a path that made no sense for an ordinary comet. That is what makes this discovery so haunting. 3I Atlas did not blaze into our skies like a herald. It whispered. Its light was soft, its motion subtle, its presence fragile. For weeks, astronomers had to fight against the background glow of the sun, against the blur of instruments, against the chaos of the heavens themselves, just to keep track of it. It was a ghost that could have been overlooked 100 times before. And yet, for reasons we may never fully understand, this time it was seen. To the untrained eye, the first images of 3I Atlas are almost disappointing. Just a smudge, a tiny blur against a canvas of stars. But appearances deceive. That faint blur carried within it the weight of billions of years of travel. Each photon of light that reached our telescopes had bounced off an object born in the furnace of another sun, perhaps in a system now gone cold and dark. To see 3I Atlas was to look not only across distance, but across time itself. The discovery raised questions immediately. Where had it come from? What forces had thrown it out of its home system, condemning it to wander the interstellar void? And how long had it drifted before finally crossing paths with our world? Scientists compared it to the two visitors before it, Oumuamua in 2017 and Borisov in 2019, but quickly realized that this new arrival had its own strange story. Unlike Borisov, it was faint and difficult to track. Unlike Oumuamua, it showed signs of outgassing, yet in ways that defied normal expectations. Even in its first days of observation, 3I Atlas refused to fit neatly into categories. The ghostly nature of its discovery also sparked the imagination outside the scientific community. People asked, how many others have slipped past unnoticed? If 3I Atlas could appear so quietly, perhaps thousands of such travelers pass through the solar system each millennium, their faint trails never caught by our instruments. We may be living in a cosmic harbour where strangers dock often, invisible except to those watching with relentless patience. There is something profoundly humbling in that thought. Humanity often imagines itself at the centre of things, but 3I Atlas reminded us that we are not the audience, it is the passerby. It did not come for us, it did not slow to greet us, it merely drifted into view, lingered for a short time, and then moved on, indifferent to whether we noticed at all. And yet, by noticing, we gave it a place in our story. If you imagine the universe as a vast stage, 3I Atlas was like an actor stepping briefly into the spotlight before vanishing into the wings. Its presence was fleeting, its lines unsaid, but the silence it left behind was more powerful than words. A ghostly discovery, yes, but one that lingers in the imagination because it suggests that the universe is full of wanderers we have not yet seen. The discovery of 3I Atlas is a reminder of how fragile knowledge can be. If clouds had obscured the sky that night, if the telescope had been looking a fraction of a degree away, if the data had been ignored as noise, this visitor would have passed unnoticed. We would have remained unaware that, for a brief time, a traveller from another star crossed our skies. It is humbling to think how much of the universe we still miss, how much drifts silently beyond our sight. And so, 3I Atlas was not just an object, it was a lesson, a reminder that the universe is larger than our imaginations, that discovery is often a matter of patience and luck, and that even ghosts, faint, fleeting and fragile, can carry with them the weight of galaxies. It slipped into our skies like a whisper, almost unseen, but it left us with questions that may echo for generations. How many more wanderers are out there? How many more ghosts cross our path unnoticed? And what will we learn when the next faint light reveals itself against the stars? Not of our sun, why its hyperbolic orbit proves it will never return. When astronomers first mapped the faint trail of 3I Atlas across the heavens, the numbers told a story stranger than the light itself. Unlike the graceful ellipses carved by comets born of our solar system, its path was stretched open, hyperbolic. It was the unmistakable signature of a visitor, not a native. Where the comets we know are tethered to the sun's gravity like dogs on leashes, looping back again and again, 3I Atlas was free. It had come once, and it would never return. To picture this, imagine tossing a stone into the air. Most stones you throw arc upward, slow, and then fall back to Earth. That's an ellipse, bound to the planet no matter how high it flies. But if you could throw hard enough, so hard that the stone exceeded escape velocity, it would break free, curving outward forever, never to return. That's a hyperbolic path. 3I Atlas is that stone, hurled not just from Earth, not even from the Sun, but from some distant star system, cast into the void with enough momentum to wander endlessly across the galaxy. This is not how most comets behave. The icy wanderers of our solar system, whether from the Oort cloud or the Kuiper belt, follow predictable, repeating routes. They may take hundreds or even thousands of years, but they return. Halley's Comet, for example, is seen every 76 years, a reassuring rhythm that ties us to the cycles of our own cosmic neighbourhood. 3I Atlas, by contrast, is no neighbour. It is a stranger passing through town, already on its way to somewhere else. The fact that its orbit is hyperbolic means something profound. Our sun cannot hold it. The gravity that rules planets, moons and comets here has no claim on this traveller. It will not be pulled into a loop or trapped in a long, slow return. Instead, it will slingshot around the sun just once, gathering a little extra speed as it goes, and then vanish back into interstellar darkness. For all of human history before now, it was invisible, and for all of human history to come, it will remain invisible again. This realization carries a strange weight. For us, the solar system feels like home, a stable and orderly place where planets and comets play out their ancient patterns. But 3i Atlas reveals a larger stage, one where objects drift endlessly between stars, belonging nowhere, bound to nothing. It is like glimpsing a traveller walking down a lonely road, knowing they will never stop, never turn back, never stay. You see them once, and then they are gone forever. Hyperbolic paths also whisper about origins. To be thrown free of a star's gravity, an object must experience violence, the pull of giant planets, the chaos of a close encounter, or even the upheaval of a system tearing itself apart. 3i Atlas is proof of catastrophe somewhere long ago, an echo of events so powerful they launched it into the cold wilderness of interstellar space. For billions of years, it has been a cosmic refugee crossing the gulfs between suns. Its hyperbolic arc through our skies is not just a trajectory, it is a story of exile written in mathematics. The beauty of such a path is that it cannot be faked. Orbits obey the laws of physics, indifferent to mystery or speculation. When astronomers see a hyperbola, they know what it means: freedom. No comet from the Oort cloud can wander into such a shape. No asteroid, no planetesimal bound to the sun can carve such a line. 3i Atlas bears the unambiguous mark of being not of our sun, and yet in that clarity lies a kind of melancholy. Because we know that once it is gone forever. We will never study it up close, never send a probe fast enough to chase it, never learn more than what its brief flicker revealed. Its hyperbolic orbit is not just mathematics, it is farewell written in the stars. For those who watched it through telescopes, this realization adds a haunting note. Every photon of light, every measurement of its gases and dust feels like a message scribbled on a passing scrap of paper caught in the wind. If you do not read it now, it will blow away into darkness. Humanity had only a brief moment, a window of months, to learn what it could before the visitor slipped away, never to be seen again. And so the hyperbolic orbit of 3i Atlas is more than just a curve on a chart. It is a reminder that the universe is not bound to the cycles we find comforting. Some things do not return. Some visitors pass once through our skies, leave us with questions, and continue on their endless way. They are not of our sun, not of our home. They belong to the greater galaxy, and we are merely lucky or unlucky enough to have glimpsed them in passing. When we look back on this ghostly visitor, what lingers is not only the strangeness of its chemistry or the mystery of its origins, but the path itself, a hyperbolic farewell written across the canvas of the night, a reminder that some stories touch us only once before vanishing into forever. Speed without mercy, why 3i Atlas races faster than most comets. When astronomers first charted the motion of 3i Atlas, one fact stood out more than any other: its speed. Unlike the comets that loop lazily around the sun, drifting through centuries-long orbits, 3i Atlas tore across the solar system with a velocity that felt almost merciless. It was fast enough to ignore the sun's pull, fast enough that no spacecraft humanity has ever built could hope to chase it. Its path was not the winding arc of a neighbour, but the headlong sprint of a stranger passing by. To grasp this, it helps to picture the comets we know. Halley's Comet, the most famous of all, travels at about 157,000 miles per hour near perihelion. That sounds staggering, and yet it remains bound to the sun, its orbit stretched but loyal, destined to return every 76 years. 3i Atlas, by contrast, raced even faster, its hyperbolic speed boosted by ejection from another system long ago. It was a stone flung not just high, but so hard that it escaped entirely. In cosmic terms, it is the difference between a bird circling a tree and one that migrates across an ocean, never to return. Why so fast? The answer lies in violence. Objects do not simply drift into interstellar space, they are thrown. Somewhere in its past, 3i Atlas must have encountered forces powerful enough to break its leash. Perhaps it passed too close to a massive planet in its home system, a giant like Jupiter that flung it outward with gravitational slingshot speed. Or perhaps its star was part of a cluster and another star brushed too near, scattering its comets like sparks from a fire. Some even speculate that it could have been born in a system that no longer exists. A world shattered, its debris scattered into the void, of which 3i Atlas is just one surviving fragment. Whatever the cause, the speed is a scar, a record of trauma billions of years old. Like a refugee carrying the marks of a long journey, 3i Atlas races forward with no thought of stopping. It is not slowed by atmosphere or by gravity wells, only nudged slightly by the sun's pull as it slingshots away. The numbers are cold, but they whisper of struggle, something powerful enough to fling an icy body into exile, condemned to wander the galaxy forever at a speed that ensures it will never rest. To put this into perspective, consider humanity's fastest creations. The Parker Solar Probe, designed to skim close to the Sun, is the fastest spacecraft we have ever launched, traveling at around 430,000 miles per hour. Even at that incredible velocity, it would still struggle to match 3i Atlas's trajectory, arriving years too late to catch up. Voyager 1, our most distant emissary, drifts outward at a mere 38,000 miles per hour, an impressive number in human terms, but a crawl compared to the relentless sprint of 3i Atlas. Against such a traveller, our technology feels almost still. This is what makes its speed so haunting, not just that it is fast, but that it reminds us of our own slowness. We stand on the shores of a cosmic ocean, watching driftwood race past, unable to swim out to meet it. For all our rockets and probes, we remain bound to the solar system, while 3i Atlas carries secrets of other suns beyond our reach. Its speed is a taunt, a reminder that the universe moves on scales we can barely imagine. And yet, speed does not only mean distance, it also means fragility. A comet racing so quickly through interstellar space must endure collisions with dust and radiation that would erode lesser bodies. That 3i Atlas has survived this long suggests a resilience we do not yet understand. Each mile per second is a story of survival. Each orbit plotted is proof that even fragile ice can endure the harshest journeys if hurled fast enough. There is a kind of poetry in this merciless pace. Imagine watching a train roar past at midnight, its lights flickering for only a moment before vanishing into the dark. That is what 3i Atlas was for astronomers, a brief glimpse of something vast and unstoppable. It will never slow, never linger. It will not give us a second chance. Its speed is both its shield and its farewell. Perhaps that is why it captures the imagination. In its motion, we see both the violence of its birth and the impossibility of its return. We see the limits of our own reach and the vastness of the galaxy beyond. 3i Atlas does not wait for us. It does not bend to our timelines or our technology. It races without mercy, carrying mysteries we may never solve, a reminder that the universe does not move at the pace of humanity. It moves at its own. And so, when we speak of 3i Atlas, we are really speaking of that fleeting encounter, that moment when something infinitely older and faster crossed our skies. Its speed ensures it will never be ours to hold, only ours to witness as it rushes past, indifferent to whether we noticed at all. Frozen strangeness. the bizarre chemistry Webb uncovered. When astronomers turned the powerful eyes of the James Webb Space Telescope toward 3I Atlas, they expected to confirm what centuries of comet science had already taught them. A comet, whether from our solar system or beyond, should breathe in familiar ways: frozen water vaporizing as sunlight strikes, carbon monoxide and methane joining the outgassing plume, dust trailing behind like a ghostly veil. But what Webb saw in the faint light of 3I Atlas was something that startled even seasoned scientists. Its chemistry was wrong. Instead of the familiar signatures of water ice or carbon monoxide, Webb detected an unusual dominance of carbon dioxide, a composition so unexpected that it immediately raised questions. Why would a comet formed in another star system exhale gases in such strange proportions? Was it a quirk of its formation environment, a sign of alien conditions where it was born, or was it evidence of some process we have never witnessed before? To understand why this is so strange, picture baking bread. Most loaves rise the same way, with yeast and flour combining into something predictable. Imagine now a loaf that swells and cracks, but with no yeast, no familiar process, just some other ingredient doing the work. 3I Atlas was that alien loaf. It behaved like a comet, but the recipe was all wrong. Carbon dioxide is not absent from our solar system's comets, but it is rarely the star player. In most known comets, water ice is the dominant substance, often making up the vast majority of the outgassing. Carbon monoxide sometimes takes the lead in colder, more distant comets, but carbon dioxide rarely rules the stage. To see it dominate 3I Atlas's emissions suggested a birthplace far different from the cold cradle of our own Oort cloud. The implications are vast. Perhaps 3I Atlas formed closer to its home star, where conditions favoured CO2 ice over water. Or perhaps it was born in a region rich in strange volatiles, materials that condensed differently than anything we know. Another possibility is that it spent eons wandering interstellar space, bombarded by radiation that slowly stripped away its lighter ices, leaving carbon dioxide as a stubborn survivor. Each theory paints a different picture of its origin, each as mysterious as the last. And then there is the unsettling thought that Webb's detection may not be telling the full story. Could there be other compounds hidden in its chemistry, signatures we do not yet recognize? Some researchers have speculated that interstellar objects might carry exotic ices never seen in our solar system, products of stars richer or poorer in certain elements, or of planets with environments alien to our imaginations. If so, then 3I Atlas is not just a visitor, it is a messenger carrying recipes from kitchens older and stranger than our own. The public fascination with this discovery grew quickly. If its chemistry was unlike anything we know, could that hint at something more than natural processes? Conspiracy theorists leapt on the Webb data, asking whether chemical anomalies might be signals, intentional markers etched into the spectrum like codes. It is not a new idea. Carl Sagan once speculated about the possibility of chemical signatures as messages, but 3I Atlas reignited it with force. The thought that its gases might not just be chemistry but communication turned a quiet discovery into something tinged with cosmic drama. Even without such speculation, the sight of an interstellar object breathing in strange proportions carries emotional weight. Think of it as hearing a foreign song carried across a vast ocean. The melody feels familiar, the rise and fall, the rhythm of a comet venting gas. But the notes are wrong, the scales unfamiliar. You recognize the form, but not the content. That is the song of 3I Atlas, sung in gases alien to our solar system, a lullaby from another sun we will never see. And so, Webb's data left us with more questions than answers. Is 3I Atlas unique, or will the next interstellar visitor breathe in equally bizarre ways? Are we glimpsing a common pattern of galactic comets? Or did we stumble upon an outlier, a comet scarred by some unimaginable history? The universe rarely gives simple answers. In its chemistry, 3I Atlas reminded us that even when we apply our most powerful instruments, mysteries remain. What Webb uncovered was not clarity, but strangeness frozen into ice. A recipe written in alien elements, a formula from a kitchen we cannot yet enter. For now, we can only watch as it fades, carrying its secrets back into the dark. Its frozen strangeness lingers like a riddle, proof that even a faint speck of light in the sky can defy everything we thought we knew about how worlds form, live and die. Dust of other worlds. Could 3I Atlas carry fragments of lost planets? When astronomers study 3I Atlas, they are not just looking at a comet, they are peering into the possibility that it might be carrying traces of worlds that no longer exist. For all we know, locked within its icy shell and dusty trails are fragments of alien planets, the powdered remains of surfaces once warmed by distant suns, now reduced to stowaways on a journey through the dark. The idea is not as far-fetched as it sounds. In our own solar system, comets often bear the scars of collisions, gravitational disturbances, and eons of cosmic weathering. When planets form, they do so in violent neighborhoods where impacts are the rule, not the exception. Chunks of rock, ice, and dust are constantly ejected, sometimes flung into interstellar space by the tug of massive giants like Jupiter. If this is true here, it must also be true elsewhere. 3I Atlas could be more than a comet. It could be a vessel carrying relics of alien cataclysms. Imagine for a moment sweeping the ashes of a campfire into a jar. Later, someone who has never seen that fire might open the jar and find not just soot but traces of wood, minerals and smoke. They could reconstruct the fire without ever having been there. 3I Atlas may be a cosmic jar like that. Its dust might carry mineral fingerprints of a long-dead planet's crust, traces of volcanic ash from alien eruptions, or carbon-rich molecules from seas that once shimmered beneath another sun. The James Webb Space Telescope and other instruments have already shown us how strange 3I Atlas's chemistry is, dominated by carbon dioxide in ways we did not expect. If its ices are unusual, why not its dust as well? A single grain could be a time capsule, a fragment of geology from a system we will never see with our own eyes. Perhaps somewhere, billions of years ago, a planet was torn apart, shattered by collision, scattered by gravity, and 3I Atlas was born from the fragments. Now it drifts across the galaxy, carrying whispers of that world like dust clinging to a traveler's shoes. This possibility becomes even more intriguing when we think about life. On Earth, dust and debris can carry spores, bacteria, and organic compounds over vast distances. Pollen drifts for miles on the wind. Microbes cling to volcanic ash that circles the globe. If such resilience exists here, could it exist elsewhere? Could 3I Atlas unknowingly be carrying microscopic fossils, molecular seeds, or chemical precursors of life from a world that once thrived but is now gone? The theory of panspermia suggests that life can spread across the cosmos on comets and asteroids, hopping from one planetary system to another over billions of years. If true, then 3I Atlas may not just be dust of dead planets. It may be the cradle of potential new ones, bearing ingredients waiting to spark under the right conditions. In that sense, its dust could represent both endings and beginnings, the remains of one world and the seeds of another. Skeptics point out that survival in interstellar space is almost impossible. Radiation, collisions, and endless time would likely strip away anything fragile. But survival, however slim, cannot be ruled out. After all, Earth itself carries evidence that life can endure in the harshest conditions. Bacteria thriving in the vacuum of space for limited periods, spores sleeping for millions of years in amber. deep-sea microbes surviving where sunlight has never reached. If such resilience is possible here, perhaps fragments of it drift with 3i Atlas now, hidden in its dust. Even if life never existed on its home system, the dust alone is priceless. Minerals forged in the pressure of alien mountains, glassy fragments from impacts, or exotic compounds born in atmospheres unlike any we know could all be hiding in its faint trails. Studying just a handful of particles could transform our understanding of how planets form and die across the galaxy. But here lies the tragedy. We may never touch it. 3i Atlas moves too quickly on a path too fleeting for any probe to intercept. Its dust will scatter into the void, unreachable by human hands. We can only imagine what secrets it carries, like archaeologists gazing at a sealed tomb they cannot open. And yet, even from afar, its presence stirs something deep in us. To know that such dust exists, drifting into our skies from another star, is to be reminded that the universe is a graveyard of worlds, and perhaps a nursery of them too. Every particle of 3i Atlas is a whisper, a fragment of a story begun elsewhere, carried here by chance, and then sent onward again into the dark. 3i Atlas is more than a ghostly traveller. It is a courier bearing the dust of other worlds. We may never know the names of those planets, never see the suns that once warmed them, but for a brief moment their remains brushed against our skies, reminding us that even in loss, the universe never forgets. It scatters its memories across the stars. The vanishing window, why it disappeared just as it grew most active. For astronomers, timing is everything. Discover a comet too late, and you only glimpse its fading trail. Point the telescope too soon, and you stare into emptiness, waiting for a ghost that has not yet arrived. With 3i Atlas, timing played a cruel trick. Just as this interstellar traveller began to stir, just as its icy body came alive under the heat of our sun, the universe pulled a curtain across the stage. It slipped behind the sun from Earth's perspective, vanishing at the very moment we most longed to watch. This is not unusual for comets, but with 3i Atlas, it carried a sting. We had only weeks to study it before it disappeared into the sun's glare, lost against the blinding flood of light. Imagine trying to study a rare bird that lands on your windowsill for the first time in history, only to have fog roll in and block the view. By the time the mist clears, the bird is gone, never to return. That was the frustration and the mystery of 3i Atlas. The timing almost seemed mocking. For billions of years, this comet wandered unseen, silent in the dark. Then, for a brief moment, it flared near our sun, its ices vaporizing, its chemistry exposed. Telescopes caught glimpses of gases and dust, unlike those of comets we know. Questions grew louder. What was it made of? What did its strange outgassing mean? What could it reveal about its alien birthplace? But just as those questions sharpened, the sun swallowed our view. The astronomy community sometimes calls this the curse of solar conjunction. When an object aligns too closely with the sun to be observed from Earth, it is the celestial equivalent of trying to spot a candle against the blinding beam of a searchlight. No matter how powerful the telescope, the glare wins. For 3i Atlas, the timing could not have been worse. We lost the chance to see its brightest, most revealing phase, the moment when its frozen heart spoke most clearly. To some, this was simply bad luck, a reminder of the limits of Earth-based observation. But to others, it carried a sense of eerie irony. Why should one of the rarest visitors in history slip away just as it was about to tell us the most? Conspiracy theories sprouted almost immediately. Whispers that agencies like NASA had seen more than they admitted, that information was withheld under the convenient excuse of solar glare. If 3i Atlas carried secrets too strange or too unsettling to reveal, what better cover than the sun itself? Of course, the scientific explanation is more grounded. Comets are fickle things. They brighten suddenly, then fragment, then fade. Many of our own solar system's comets have vanished into obscurity after dramatic flares. 3I Atlas may simply have been too fragile, crumbling under the heat, its glow sputtering as its body broke apart. When it emerged again from behind the sun, faint and weakened, it was no longer the luminous beacon astronomers had hoped to study. Yet even the sober explanation does not erase the feeling of loss. It is as though we had been handed a book from another civilization, opened to the first pages, and then had it snatched away before we could read the rest. For scientists, the frustration lingers. For dreamers, it deepens the mystery. What if the vanished light carried answers? What if, in those lost days, 3I Atlas revealed something extraordinary, something we missed forever? There is also a haunting beauty in the timing. 3I Atlas did not blaze across the sky for the world to see, like a comet in ancient times, inspiring myths and omens. It came quietly, grew brighter only for a few careful eyes, and then vanished in the overwhelming light of the star that rules our skies. Its story is one of whispers, of fleeting glimpses, of opportunities half grasped. Perhaps that is what makes it so compelling. If it had lingered longer, revealed itself fully, perhaps it would have been catalogued, explained, and shelved neatly in our understanding. Instead, it slipped away, leaving us with fragments of data, unanswered questions, and the enduring ache of the almost known. Its vanishing window turned 3I Atlas from a mere comet into a legend. The traveller that arrived whispered its strangeness, and then disappeared before we could truly hear. And so we are left with a paradox. The most active, most revealing phase of 3I Atlas is also the part we will never see. The curtain fell too soon, whether by chance, by nature, or, as some whisper, by design. The universe allowed us only a fleeting look, a reminder that discovery is not always about answers, but about mysteries that slip through our fingers, leaving only wonder in their wake. A mirror to Oumuamua, what a TLAS shares with its mysterious cousin. When Oumuamua streaked through the solar system in 2017, it shook astronomy to its core. Nothing like it had ever been seen before. A long, tumbling shard of rock and ice, its brightness flickering strangely, its orbit undeniably interstellar. For weeks, the world debated whether it was simply a comet behaving oddly or something else entirely, perhaps even artificial. That debate has never fully gone away. Years later, when 3I Atlas was discovered, the memory of Oumuamua immediately resurfaced. Astronomers and the public alike could not help but draw parallels. Here was another hyperbolic traveller, another ghost from beyond the sun, another fleeting chance to study the strange and the unfamiliar. In many ways, 3I Atlas became a mirror held up to Oumuamua, reflecting both our progress in understanding interstellar visitors and the persistence of mysteries we cannot yet solve. Both objects shared the same unearthly passport. They did not belong to our solar system. Their hyperbolic trajectories marked them as outsiders, slipping through with no return. This alone made them kin, part of a tiny family of wanderers we have been lucky enough to glimpse. But the similarities did not end there. Both arrived quietly, without spectacular displays visible to the naked eye, requiring sharp eyes and patient instruments to even notice them. Both tested the limits of our technology and imagination, forcing us to ask, how much are we missing, and how often do such visitors pass unseen? And yet their differences are just as striking and instructive. Oumuamua, for all its oddities, was largely a silent traveller. It showed no clear signs of outgassing, no tail, no plume, just a shifting brightness that suggested a strange, elongated shape. 3I Atlas, in contrast, did exhale, though in ways that defied our expectations. Its emissions were dominated not by water vapor but by carbon dioxide, a bizarre imbalance that puzzled scientists and hinted at a birthplace unlike any world we know. Where Oumuamua was enigmatic in its silence, 3I Atlas was enigmatic in its strange voice. Together, they form a kind of duet. Oumuamua raised the possibility that interstellar objects could be unlike anything we had catalogued, shapes that made no sense, behaviors that left us speechless. 3I Atlas confirmed that strangeness was not an exception, but perhaps the rule. If the first interstellar visitor had been odd and the second ordinary, we might have chalked Oumuamua up to a fluke. But with 3I Atlas, we learned that each traveller may bring new puzzles, new surprises, new reasons to doubt what we think we know. The mirror between the two also reflects our own human responses. When Oumuamua appeared, speculation ran wild. Books, articles, and even scientific papers dared to suggest it could be a probe, a relic of alien engineering. With 3I Atlas, the theories were tempered, but no less imaginative. The chemistry raised whispers of encoded messages, while its faint, vanishing glow fueled suspicions of cover-ups. Each object became not only a discovery, but a canvas, onto which humanity projected its hopes, fears, and suspicions about life beyond Earth. Think of them as travellers on different roads, passing through the same small town. One walked silently, cloaked and strange, leaving only footprints in the dust. The other paused to speak, but in a language we could not quite understand, vanishing before we could translate. Both encounters remind us of how fleeting and fragile our opportunities are, how much of the universe slips past while we are still fumbling to listen. The most haunting thought is this: Oumuamua and 3I Atlas may not be rare exceptions. They may be hints of a hidden stream, a quiet migration of cosmic debris flowing through our solar system far more often than we realize. If two visitors so different arrived within just a few years of each other, how many more wander unseen, their paths never aligning with our telescopes? Perhaps our skies are busier than we think, filled with messengers whose stories we never hear. 3I Atlas, in this way, is not just a mirror to Oumuamua, it is a continuation of its legacy. Together, they form the opening chapters of a story we have only just begun to read. Both remind us that the universe is far stranger than our textbooks suggest, and that every visitor is not an answer but another question. When we look at 3I Atlas, we are really looking at Oumuamua again, and beyond that, at ourselves, at the limits of our vision, the persistence of our imagination, and the mysteries we may never fully solve. The mirror shows us not only what they share with each other, but what we share with them, the endless longing to understand the unknown, even when it slips through our fingers like dust in the dark. Between science and suspicion, NASA's careful words on 3I Atlas. When 3I Atlas first appeared in the sky as a faint smudge of light, NASA responded with its usual voice, measured, precise, and cautious. The official statements described it as a confirmed interstellar comet, highlighted the uniqueness of its chemistry, and emphasized what it was not: a danger to Earth. This language was familiar, almost comforting, the same tone NASA often uses when addressing asteroids, comets, or meteors that stir public imagination. But for some, that very calmness fueled suspicion. Why, people wondered, did NASA always seem to downplay the strangeness of these visitors? Oumuamua had already ignited debates in 2017, with some scientists daring to suggest it might be artificial. When 3I Atlas arrived, NASA stressed stability, focusing on its classification, orbit, and the lack of threat. To scientists, this was responsible communication. Never exaggerate, never sensationalize, always anchor the message in data. But to others, especially those inclined toward conspiracies, such careful words seemed less like clarity and more like concealment. It's a tension as old as science communication itself. On one side, researchers know the danger of overstating mysteries. A claim of alien origin once spoken can overshadow decades of sober work. On the other side, the public lives in a world where mystery sells and silence feels like secrecy. 3i Atlas, with its bizarre chemistry and fleeting appearance, was the perfect canvas for both approaches. Science sought to measure, while imagination sought to fill the gaps. Consider how NASA's statements are crafted. Instead of saying, "We don't know," they often say, "More data is needed." Instead of calling something strange, they say, "Unexpected." This precision avoids panic, but it also leaves space for suspicion. When NASA reported that 3i Atlas had an unusual CO2 dominance, it was a factual description. But for the wider audience, it sounded like an understatement, like describing a ghost as a faint anomaly in local light behavior. This isn't unique to 3i Atlas. When objects pass close to Earth, NASA emphasizes how unlikely a collision is, even when the numbers show a razor-thin chance. When instruments detect signals from space, NASA stresses natural explanations, wary of jumping to conclusions about intelligence. The agency has learned that the world listens closely, ready to twist every word into a headline. In this climate, caution is not just science, it is survival. And yet, the careful tone feeds a different kind of narrative that NASA knows more than it lets on. The idea of hidden files, classified findings, and cover-ups has been part of UFO culture for decades. 3i Atlas's strange behavior gave that culture fuel. Why emphasize safety so quickly, some asked, unless there was more to fear? Why describe its chemistry in such flat terms, unless its true nature was more dramatic? Silence, in a vacuum of trust, becomes a shadow that grows longer. It's important to remember that NASA is not a single voice. Behind every press release are teams of scientists debating language, deciding which numbers matter most, weighing the balance between clarity and caution. Many of those scientists, late at night, likely whispered their own wonder. What if this visitor carries something we cannot explain? But their public duty is different. They are guardians of tone as much as truth. This divide between science and suspicion reveals more about us than about 3i Atlas. For those who seek stability, NASA's voice is reassuring. For those who crave mystery, it sounds suspicious. The comet itself does not change, but the way we hear it depends on what we already believe. 3i Atlas became not just an object in the sky, but a mirror for our trust, our doubts, and our hunger for the extraordinary. In the end, NASA's careful words may be both a shield and a seed against panic, against sensationalism, against turning fragile data into headlines that mislead, but also a seed of curiosity planted in the gaps between what is said and what is not. Suspicion grows where certainty is absent, and in the quiet tones of official statements, imagination fills the silence. And so 3i Atlas lived in a liminal space between science, which insists on restraint, and suspicion, which thrives on uncertainty. The comet itself was a faint light against the stars, but the words around it were louder, shaping its story long after its glow had faded from the sky. The global chase, how telescopes worldwide turned to follow it. When 3i Atlas first appeared, faint and uncertain against the background of stars, its discovery was only the beginning. To confirm its path, to understand its nature, and to grasp even a fragment of its story, the world had to look together. No single telescope could follow it long enough, no lone observatory could capture all the data before it slipped away. And so began what some called the global chase, a quiet, coordinated pursuit of a ghost racing through our skies. It was a race against time, Unlike planets, which trace patient orbits we can predict for centuries, or even ordinary comets that circle back after decades, 3I Atlas was a one-time visitor. Once it was gone forever. Astronomers knew this window would not open again. They had weeks, months at best, to gather as much information as possible before the faint glow faded beyond reach. That urgency bound together observatories scattered across continents and oceans, each watching for their turn to catch the traveller as Earth's rotation shifted the skies. From Hawaii's volcanic peaks to the deserts of Chile, from the plains of Europe to the icy outposts of Antarctica, telescopes were aimed at the same small target. In the United States, NASA and university facilities tracked its shifting arc, refining orbital models so others could point their instruments more precisely. In Spain, amateur astronomers contributed long exposure images that added detail to its faint dust tail. In Japan, cutting-edge optics measured tiny fluctuations in brightness, clues to its rotation. Even citizen scientists, armed with backyard telescopes and determination, joined the effort, uploading images to global networks where professionals could fold them into the data stream. It was a strange kind of pursuit, cooperative, not competitive. In a field where funding often fuels rivalry, 3I Atlas reminded the scientific world that some discoveries are too rare to hoard. Data was shared quickly, openly, almost urgently, as though each observatory knew the others might see something it missed. One team could not capture the whole story, but together they could sketch a fuller picture, like villagers piecing together rumours of a traveller passing through town. The challenge was immense. 3I Atlas was faint, slipping in and out of view, often lost in the glare of the sun. Tracking it meant hours of patient exposure, balancing instruments against atmospheric interference, waiting for moments of clarity in skies that are never truly still. It was, in many ways, like chasing a whisper across a crowded room. But astronomers are practiced listeners, and with enough ears tuned to the sound, the whisper became a voice. And what a voice it was! The combined observations revealed chemistry no one expected, a hyperbolic path confirming its alien origin, and a brightness that seemed to fluctuate in ways still not fully understood. Each telescope contributed a different piece. Webb's infrared eyes uncovered its frozen strangeness, while ground-based instruments traced its dust trails. Together, they told a story no single view could reveal, a story of exile, of survival, of a body born under another sun and wandering across the galaxy. For those outside the scientific community, the global chase carried its own mystique. It was not just about data, it was about humanity's shared curiosity. In a world divided by borders and politics, here was a moment where nations worked in unison, gazes turned upward at the same patch of sky. The pursuit of 3I Atlas was a reminder that wonder can unite us, even if only for a passing visitor that would soon be gone. There is poetry in the thought that 3I Atlas, an object born billions of years ago in some distant system, became the center of attention for an entire planet. Humans on mountaintops and in city observatories, in desert outposts and snowy stations, all pointed their instruments at the same fleeting light. For a brief span of weeks, the Earth itself seemed to tilt its collective gaze outward, chasing a traveller who would never return. And then, just as quickly, it was over. The comet faded, slipping behind the sun, growing too dim for even the best instruments. The chase ended not with a dramatic capture, but with silence. But the data remained, a mosaic assembled from countless nights of watching, countless pairs of eyes turned upward together. The global chase of 3I Atlas was more than a scientific effort. It was a moment of unity, a reminder that even in our fractured world, we can come together to pursue the mysteries beyond us. A faint speck of light drew us into collaboration, and in chasing it, we glimpsed not only an alien traveller, but also our own shared hunger to know the unknown. The whispering tail. Why its plume seems to flicker like a message. When people picture a comet, they imagine a long, elegant tail stretching across the sky, glowing softly as sunlight strikes dust and ice. But with 3i Atlas, things were different. Its tail did not shine with the steady grace of comets we know. Instead, it flickered, brightening and dimming, breaking apart and reforming as though it were trying to speak in a language of smoke. To some, it was simply the chaotic physics of ice vaporizing in sunlight. To others, it felt like a whisper, a message drifting across the void. The science of comet tails is well understood, at least in broad strokes. As a comet approaches the sun, heat warms its surface, releasing gases and dust in great streams. These streams, caught in the solar wind, stretch outward to form the glowing tails we admire. Most comets follow this pattern predictably, brighter near perihelion, fainter as they drift back into the cold. But 3i Atlas refused to follow the script. Its plume seemed erratic, fluctuating in ways that left even seasoned astronomers puzzled. The James Webb Space Telescope captured some of these shifts, showing that carbon dioxide dominated its outgassing, an oddity in itself. But beyond the chemistry was the pattern: sudden flares, unexpected dimming, almost like pulses. On long exposures, the tail looked broken, as if light itself stuttered. Natural explanations abound: uneven heating of its surface, jets of gas bursting through cracks, chunks of ice breaking loose and briefly catching sunlight. Yet the irregular rhythm gave rise to another possibility, one more poetic and perhaps more unsettling, that the comet's tail was more than random chaos. It is tempting, after all, to see patterns where none exist. Humans are wired for it. We find shapes in clouds, faces in shadows, melodies in static. A comet's flickering plume, when stretched across the sky, almost begs to be read. Ancient civilizations treated comets as omens, seeing in their tails messages from gods or warnings of disaster. 3i Atlas, with its strange rhythm, invited the same instinct. Was the flicker simply ice and dust? Or could it be something like writing, a signal carried not by radio waves, but by light itself? This thought is not as absurd as it first seems. Scientists have long debated what a civilization might do to send messages across interstellar distances. Radio is one method, but it fades and requires precise aim. Light, on the other hand, is universal and visible to any who watch. A comet's tail, especially one traveling between stars, could be an ideal carrier. Encode patterns in the timing of outgassing, and the plume becomes a kind of cosmic semaphore waving across the galaxy. Of course, skepticism remains the safer ground. Astronomers point out that comets in our own solar system often behave erratically. Jets of gas on Comet 67P, studied by the Rosetta mission, blasted dust in bursts, creating flickers not unlike what we saw with 3i Atlas. But still, the comparison only deepens the mystery. If our comets can produce such strange rhythms naturally, might alien comets produce them in ways that look even more like intentional codes? For those watching from Earth, the tail became a canvas for imagination. Some amateur astronomers reported seeing repeated intervals of brightening as though 3i Atlas pulsed like a heartbeat. Others claimed to trace shapes in the dust, faint arcs and spirals suggesting geometry rather than randomness. None of these claims have been confirmed, but they echo a timeless truth. When faced with the unknown, humanity listens not only with its instruments, but with its longing. There is also something deeply emotional in the idea of a whisper. The universe is vast, dark, and largely silent. We spend billions of dollars building telescopes just to catch faint traces of light. To see a comet's tail flicker unpredictably is to wonder if, just maybe, the silence has been broken. What if this traveller, older than Earth itself, carries not only dust of other worlds, but also intention? What if its plume, dancing in and out of brightness, is the closest thing to a message we have ever received? Even if the truth is mundane, the feeling lingers. Watching Three-Eye Atlas's plume is like hearing static on an old radio late at night, half expecting to catch a voice among the noise. Perhaps it is only chance, only physics. But perhaps, hidden in the chaos, lies a signal we have not yet learned to read. The whispering tale of Three-Eye Atlas leaves us with that haunting possibility that messages may already surround us, woven into patterns we dismiss as random, waiting for the day when our ears or our eyes are finally tuned to listen. Older than Earth, how Three-Eye Atlas may predate our solar system. When we look at Three-Eye Atlas, it is tempting to see it as something fleeting, a smudge of light in a telescope, a traveller that drifts briefly into our skies and then vanishes. But hidden within that faint glow is a far deeper story, one that stretches back before Earth itself was even born. There is strong reason to believe that Three-Eye Atlas is older than our planet, perhaps older than the Sun, older even than the orderly family of worlds we call home. To grasp this, we need to remember how young our solar system really is. By cosmic standards, it is a teenager, just 4.5 billion years old. The Milky Way galaxy, by contrast, has been churning out stars for more than 13 billion years. Many suns lived and died before ours ever flared into light. Whole systems formed, flourished, and collapsed while Earth was still only a possibility. Three-Eye Atlas could be a survivor from one of those earlier times, a relic from a star system long forgotten, carrying in its frozen body the history of an age when our sky did not yet exist. Imagine holding a stone in your hand that predates humanity, not just by centuries or millennia, but by billions of years. That is what astronomers believe Three-Eye Atlas may be, a stone shaped in another system, under another sun, perhaps from a planet or disk of gas and dust older than anything in our neighborhood. When you gaze at it through a telescope, you are not just looking into distance, you are looking into deep time. How could something so small endure so long? The answer lies in the nature of exile. A body ejected from its home star system enters interstellar space where nothing much happens. No atmosphere to erode it, no strong gravity to break it apart, no planetary collisions to shatter it. In the emptiness between stars, time moves differently. An object can wander for billions of years unchanged, like a bottle drifting across an endless ocean. Three-Eye Atlas may have been wandering since before the Earth's crust hardened, carrying in its chemistry the fingerprint of a galaxy still young. This possibility adds weight to its strange composition. The James Webb Space Telescope found that Three-Eye Atlas exhaled mostly carbon dioxide, a surprising dominance that does not match most solar system comets. What if this is not just oddity, but evidence of age? Perhaps it formed under conditions no longer common, when the galaxy's chemistry was different, when ancient stars seeded space with materials unlike those we see today. To study Three-Eye Atlas is to study the galaxy's childhood, preserved in ice. There is a haunting beauty in this idea. Earth itself is restless, continents shift, volcanoes erupt, seas rise and fall. No rock here remains unchanged for billions of years, but Three-Eye Atlas is different. It may be the closest thing we have to a time machine, an untouched remnant from a cosmic era we can never visit. When astronomers catch even a glimpse of its dust, they are touching the memory of a galaxy older than our sun, older than our home, older than everything familiar. Some go further, suggesting that interstellar comets like Three-Eye Atlas may be not just relics, but messengers. If it carries fragments of ancient worlds, minerals forged in forgotten planets, carbon compounds shaped in alien seas, Then it carries with it the voices of times and places erased from the universe. Stars die, planets shatter, civilizations rise and fall, but comets endure, wandering witnesses to stories no one else remembers. It is unsettling, too, to realize how casually it passes us by. Here is an object older than Earth, slipping silently through our skies and then gone forever. For all our telescopes and all our knowledge, we had only a brief window to see it, a handful of nights to collect its light. Then it vanished, leaving us with questions we may never answer. The galaxy is filled with such relics, but they do not wait for us. They move at their own pace, indifferent to whether we notice. And yet, perhaps the noticing is what matters most. To glimpse 3I Atlas is to be reminded of our place in the story of time. We are young, fragile, brief. It is ancient, enduring, untouchable. The contrast humbles us, but also inspires. Because if such travellers can survive the gulfs of time and space, perhaps fragments of our own world, our own story, may one day do the same. 3I Atlas may be older than Earth, but for a moment their paths crossed. And in that crossing, the memory of ancient stars brushed against our modern eyes, reminding us that the universe is not just vast in space, but vast in time, and that sometimes the past drifts quietly into the present, glowing faintly before vanishing into the dark once more. Survivor of collisions, what it endured in the interstellar void. To understand 3I Atlas is to understand survival on a scale that dwarfs anything on Earth. For billions of years, it has wandered through the black wilderness between stars, a fragile body of ice and dust that somehow endured a journey that should have destroyed it 1,000 times over. Every crack in its surface, every particle embedded in its skin, is a scar from encounters with a hostile cosmos. It is not just a comet, it is a survivor. Space may look empty, but it is not gentle. The interstellar void is laced with hazards, stray dust grains moving at tens of thousands of miles per hour, streams of high-energy radiation from exploding stars, and the invisible tug of distant gravitational fields. To a body like 3I Atlas, even a collision with something the size of a pebble could be catastrophic. Imagine driving a car down a highway where every few miles someone fires a bullet into your windshield. That is what interstellar travel is like for a comet. Yet 3I Atlas endured. Scientists believe that comets survive such ordeals because of their small size and loose, porous structure. Instead of shattering under impact, they absorb it, like a sponge punched in slow motion. Layers of dust and ice cushion the blows, each collision leaving only faint marks. Over billions of years, this process sands them down, rounding their shapes, stripping away the delicate, leaving only what is tough enough to persist. 3I Atlas, then, is not just a traveller. It is what remains after endless attrition, the distilled essence of survival itself. Radiation is an even harsher enemy. Cosmic rays, streaming endlessly across the galaxy, strike any body adrift in the void, slowly altering its chemistry. Water ice darkens, carbon compounds mutate, bonds break and reform. Over time, the comet's surface becomes a hardened crust, darker and less reflective, a kind of shield forged by exposure. Underneath, however, pockets of pristine ice remain, untouched since the object's birth. This is why, when 3I Atlas drew near our sun, it awakened. Heat pierced the crust, releasing ancient gases like a breath held for eons. To us, that outgassing seemed bizarre and unfamiliar, but in truth, it was the voice of a body shaped by survival. Consider what this means in human terms. If Earth itself endured billions of years of collisions, it did so by reshaping. Continents rose and fell, oceans boiled and froze, life evolved and vanished. 3I Atlas had no such mechanisms. It could not heal, rebuild, or adapt. It could only endure, absorbing blows, losing fragments, but continuing forward, carried by momentum that began in some distant system long before Earth was formed. There is a strange poetry in imagining its journey. Picture a lonely ship adrift on a stormy ocean, its sails shredded, its hull battered, yet still afloat. Each wave threatens to sink it, but it rides on, scarred but unbroken. 3i Atlas is that ship, a relic of another harbour, tossed into the currents of the galaxy. Its survival is not triumph in the heroic sense, but persistence, the quiet refusal to vanish, even when all odds say it should. This survival has consequences for us. Every scar, every strange chemical trapped in its ice, tells a story about the environments it has passed through. The galaxy is written into its body, the radiation of nearby supernovae, the dust of star-forming regions, the violence of its ejection from its home system. Studying it is like reading a diary where most pages are smudged, but the margins still whisper of ancient storms. Some wonder whether its survival hints at something more. If an object as fragile as a comet can endure billions of years of travel, could more complex structures, machines, spores, even dormant seeds of life do the same? 3i Atlas becomes in this sense a proof of concept. If it can survive the void, maybe other travellers, natural or artificial, are out there too, still wandering, still enduring, waiting for discovery. And yet, there is a haunting irony. The very journey that proves its endurance also ensures its exile. 3i Atlas has travelled so far and so fast that it will never stop, never return, never rest. Its survival is endless motion, a life without home. It will outlast civilizations, perhaps even stars, carrying its scars into futures we cannot imagine. When astronomers caught sight of it, they were not just seeing a comet, they were seeing a testament to resilience, a body that had endured collisions, radiation, and the cold silence of interstellar space for longer than Earth has existed. A survivor not by choice, but by chance, drifting onward with the quiet dignity of something that has been tested by time itself and has not yet fallen. Symbols in the dust. Could chemistry itself carry hidden meaning? When astronomers study a comet, they are not just looking at light or ice. They are reading chemistry, the fingerprints of elements and molecules released as heat from the sun awakens its frozen core. In most cases, these fingerprints follow a pattern: water, carbon monoxide, methane, ammonia, the usual suspects of cosmic ice. But with 3i Atlas, the chemistry was strange, dominated by carbon dioxide in ways that made little sense. For scientists, this raised questions about its birthplace. For dreamers, it raised another. Could chemistry itself be more than nature? Could it be meaning? Could it be message? It is not an entirely new idea. For decades, thinkers have speculated that an advanced civilization might not use radio waves to communicate, but something more enduring, something woven into matter itself. Imagine encoding a message not in sound, but in the ratios of elements, the distribution of isotopes, or the layered release of gases. A comet drifting between stars could become a message in a bottle, carrying not words, but symbols written in chemistry. 3i Atlas almost seemed to invite this speculation. Why so much carbon dioxide and so little else? Why the odd shifts in brightness as though jets of gas switched on and off in a rhythm? Of course, science provides possible answers. Perhaps it formed in a system where CO2 was abundant, or perhaps cosmic radiation stripped away lighter ices over billions of years. But the thought lingers. What if the imbalance was intentional? What if someone long ago designed the comet to breathe in a way that would stand out, to make curious minds pause and wonder? Consider how humans themselves leave symbols. We carve names into tree trunks, etch equations onto metal plates aboard spacecraft, arrange rocks into patterns that survive long after we are gone. What if another intelligence chose to work with the language of chemistry instead, knowing it would endure the longest? A radio signal fades in hours. A chemical signature embedded in ice could persist for billions of years, waiting for another civilization to stumble upon it. Skeptics rightly warn of the danger of seeing patterns where none exist. Humans are masters of projection. We find constellations in scattered stars, faces in clouds, songs in random noise. The odd chemistry of 3I Atlas may be nothing more than coincidence, a quirk of physics and time. And yet, there is something compelling about the thought. After all, messages need not be deliberate to be meaningful. Even if the strange ratios are natural, they are still symbols, unintentional but profound, of the place where 3I Atlas was born and the history it endured. Think of an old coin pulled from the ground. Its markings may not have been intended for you, but they still tell you of the culture that minted it, the hands that used it, the age it passed through. 3I Atlas is like that coin, tossed into the dark long ago, its chemistry the inscription. Whether nature wrote the words or someone else did, the meaning is there for us to find. Some go further, suggesting that if 3I Atlas were artificial or modified, it could be a kind of beacon. A civilization wary of broadcasting signals might instead seed the galaxy with objects carrying encoded instructions, relying on chemistry as the universal language. Ratios of gases could be binary code, isotopic anomalies could be punctuation, outgassing patterns could be pulses, a flickering light that says, "We were here." Of course, no such code has been found in 3I Atlas. The data, as far as we can tell, points only to chemistry, strange but natural. But perhaps we do not yet know how to read it. Just as ancient carvings looked like meaningless scratches until someone cracked their code, the signatures in cometary dust might hold structures we cannot yet decipher. Whether intentional or not, the idea transforms how we see 3I Atlas. Its tail is no longer just a plume of ice and dust, it becomes a script written across the sky. Its outgassing is no longer random, it is a rhythm, a cadence, a possible sentence. Even if it is only the language of nature, it speaks of alien stars, of cosmic violence, of survival in the void. That, too, is meaning. So when astronomers say they are studying its chemistry, what they are truly doing is listening. Listening for a pattern in the whisper of molecules, for a symbol hidden in the dust. Perhaps all they will hear is silence, or perhaps someday they will realize that the silence was speaking all along. The shadow of conspiracy, why some suspect cover-ups. From the very first announcement of 3I Atlas, NASA and other agencies were careful. They spoke of trajectories, light curves, and chemistry. They stressed that it posed no danger, that its path would carry it harmlessly past Earth, that it was simply another interstellar visitor. The tone was calm, measured, professional. Yet for some, this very calmness was suspicious. Why, they asked, did the words feel so carefully chosen? Why did it sound less like an exciting discovery and more like controlled reassurance? Out of that doubt grew the shadow of conspiracy. Conspiracy has always walked hand in hand with the unknown. When a light flashes in the sky, when a signal appears and vanishes, when a comet behaves strangely, the absence of certainty becomes fertile ground for imagination. 3I Atlas was the perfect stage. It was faint, fleeting, bizarre in chemistry, and vanishing behind the sun at the very moment it became most interesting. To many, that timing felt almost too convenient, like a curtain pulled across the sky. Theories spread quickly online. Some claimed that NASA had observed something extraordinary, perhaps signals hidden in its outgassing, perhaps fragments that looked artificial, and chose not to share it. Others suspected that military agencies had taken over, shifting telescopes to secrecy under the cover of solar conjunction. A few went further, suggesting that 3I Atlas was not a comet at all, but a craft, and that silence was part of a long-running cover-up to shield humanity from panic. What fuels these suspicions is not only the strangeness of the object, but the history of mistrust. Roswell, in 1947, still lingers in the collective memory. Government denials in the face of UFO reports have seeded the belief that authorities always know more than they admit. When scientists say, "We need more data," many hear, "We already know, but won't tell." When NASA emphasizes no threat, some hear, "The threat is worse than you think." The gap between scientific caution and public imagination is wide, and in that gap, conspiracy thrives. Consider also the language of science itself. Astronomers describe 3I Atlas's carbon dioxide dominance as unexpected. To a scientist, this means new and interesting. To the layperson, it sounds like unexplained and possibly alarming. Words meant to dampen fear instead fan it. And when official statements avoid speculation, because speculation is not science, they leave space for others to fill with wilder narratives. In this way, silence becomes fuel. Even the global chase, which united observatories around the world, was interpreted through this lens. To most, it was proof of scientific collaboration. To others, it looked like secrecy. Too many telescopes pointing at one faint light. Too much urgency for something described as harmless. Why so much attention if it was truly nothing? Why the rush of data sharing, the rapid refinement of models? For those who mistrust institutions, these efforts looked less like excitement and more like evidence of hidden importance. The truth, of course, is simpler and more complex at once. 3I Atlas was extraordinary, but extraordinary in a scientific sense. Its chemistry and path challenged our models, raising questions about how star systems form and eject their comets. That was reason enough for urgency, but in the shadows of conspiracy, no explanation is ever enough. Absence of certainty will always be read as presence of secrecy. And perhaps, in a way, that is natural. Humanity has always sought patterns in the unknown. When ancient peoples saw comets blazing across the night sky, they read them as omens of war or death, messages from gods or spirits. Today, we have telescopes instead of temples, press releases instead of prophecies, but the instinct is the same. A visitor from another star cannot simply be ice and dust. It must mean more, and if science will not say so, then whispers of conspiracy will. 3I Atlas, then, is not just a comet in the night. It is also a mirror held up to us, showing how fragile our trust is, how quick we are to suspect, how much we crave secrets hidden in plain sight. Its faint glow passed across the sky, but the shadows it cast linger in conversation, in speculation, in the suspicion that perhaps, just perhaps, there was more than we were told. Whether those suspicions are justified or not is almost beside the point. What matters is the hunger they reveal, a desire to believe that the universe is stranger than officials admit, that we live not in a quiet galaxy, but in one teeming with secrets. 3I Atlas may be gone, its window of visibility closed, but the shadow of conspiracy it left behind is not so easily dispersed. It lingers, whispering that in every silence there might be more than meets the eye. The great filter at the door is a TLAS proof we are being watched. Among the many mysteries that 3I Atlas brought into our skies, perhaps none is more unsettling than the way it rekindled an old and haunting question. If the universe is so vast and so full of stars, why haven't we met anyone else? This question, known as the Fermi paradox, has given birth to many possible answers, but one of the most chilling is called the Great Filter. The idea that most civilizations never make it far enough to explore the stars. Somewhere along the path from simple life to interstellar voyages, there is a wall, a filter, that most cannot pass. But what if the Great Filter isn't behind us? What if it waits ahead? And what if 3I Atlas, with its strange chemistry and fleeting trail, is more than just a comet? It is a reminder, or worse, a warning, that we are already being observed. The idea unsettles because 3I Atlas fits so well into the role of a silent watcher. It did not blaze like a comet meant for the naked eye. It slipped in quietly, discovered only with careful instruments. Its path was hyperbolic, ensuring it would never return, as though its visit was not to stay, but to glance, to record, and to move on. Even its chemistry, the dominance of carbon dioxide, so unlike most comets, felt alien, as though it carried not just natural ices, but a signal meant to catch attention. For those who see through the lens of the Great Filter, this raises eerie possibilities. If civilizations tend to vanish before they expand into the galaxy, perhaps the ones that survive are cautious, so cautious that they choose to hide, to scout in silence, to watch without revealing themselves. In this picture, 3I Atlas could be more than an accident of orbital mechanics. It could be a probe, a relic, or at least a test. Was Earth ready to notice? Would we recognize the strangeness or dismiss it as ice and dust? Science, of course, offers other explanations. Hyperbolic orbits happen naturally when comets are ejected from star systems. Carbon dioxide dominance might be the result of radiation stripping away other ices. Its faintness may have been nothing more than its distance and size. But the Great Filter does not rest on certainty. It rests on fear. The fear that we are fragile, that our silence is temporary, that something stronger and older already knows we exist. It helps to think in metaphors. Imagine walking through a forest at night. You shout, but no one answers. You assume you are alone until you notice a glimmer of light between the trees. A lantern, a pair of watching eyes. Suddenly, the silence is no longer comforting. It is ominous. That is how 3I Atlas felt to some. Not just a visitor, but a flicker in the dark. Proof that perhaps the forest is not empty at all. If the Great Filter is indeed ahead, then perhaps 3I Atlas is its messenger. Not in the sense of destruction, but in the sense of warning that the galaxy is not free and open, but policed. That civilizations are noticed, monitored, and perhaps when they grow too loud, removed. Its quiet passage could be the cosmic equivalent of a glance from the shadows, a reminder that we are seen. And yet, there is another way to interpret it. If 3I Atlas is proof of being watched, then it is also proof that we are not yet erased. Whatever forces guard the galaxy have let us grow this far. Let us build telescopes. Let us wonder. The comet may not be a death sentence, but a test. Can we recognize mystery without fear? Can we see strangeness without destroying ourselves? The thought lingers long after its glow has faded. Was 3I Atlas simply a natural wanderer, or was it the quiet knock of something greater, the brush of the Great Filter against our door? If it was a message, it was written in silence, subtle, fleeting, almost dismissible. But perhaps that is the point. Those who are being watched are rarely told directly. They are left to notice or not. 3I Atlas came and went, indifferent in appearance, but in its wake it left an unsettling feeling, as if we had just glimpsed a lantern in the forest. A reminder that the silence of the stars may not be silence at all. It may be the pause before the answer, the quiet moment when we realize we are not the only ones listening. When nature deceives, how strange objects trick us into thinking artificial. 3I Atlas was not the first visitor from the stars to leave astronomers uneasy. Before it came Oumuamua, the cigar-shaped wanderer of 2017 that seemed too elongated, too silent, too strange to be purely natural. Its brightness flickered as it tumbled, and it showed no ordinary tail, yet it sped up slightly, as if something invisible were pushing it. For weeks, scientists whispered the unthinkable. Could it be artificial? A probe? a derelict ship? Even in peer-reviewed journals, some dared to ask the question aloud, but as the debates cooled, so did the excitement. The acceleration, once considered odd, could be explained by faint outgassing invisible to our instruments. The elongated shape, while bizarre, might be the result of natural fragmentation. In the end, Oumuamua slipped away into the dark, leaving behind not a revelation, but a cautionary tale that nature has ways of mimicking the artificial, of tricking us into suspicion. 3I Atlas carried the same deception. Its carbon dioxide-heavy chemistry was baffling, unlike any comet in our solar system. Its plume flickered in broken rhythms, as though pulsing with intention. And it arrived, like Oumuamua, at a time when astronomers were only just learning to recognize such interstellar travelers. For many, it was impossible not to wonder, was this another sign of alien design? A probe hiding in comet's clothing? Or was it simply a reminder that the universe can produce forms and behaviors that defy our categories? Nature has always been a master of disguise. Think of Earth itself. For centuries, sailors mistook strange lights on the sea, bioluminescent plankton glowing like stars beneath their ships, for signs of spirits or omens. Meteor showers were once believed to be arrows from the gods, streaking across the sky with divine intent. Even the auroras, those shimmering veils of green and purple light, were seen as gateways to other realms. Only later did we discover they were magnetic storms, solar winds colliding with our atmosphere. The lesson is clear. What feels intentional is often natural, and what looks artificial may only be misunderstood. And yet, the suspicion is not folly, it is part of curiosity. If 3I Atlas or Oumuamua had truly been artificial, we would have needed to ask the question. Better to be wrong through wonder than blind through certainty. Nature's deceptions are not traps, but tests. They remind us how thin the line is between the expected and the extraordinary, between ordinary ice and the suspicion of messages hidden in dust. Even within our own solar system, we see echoes of this deception. Saturn's moon, Enceladus, sprays jets of water vapor into space, creating shimmering plumes that look uncannily like engines firing in the dark. Jupiter's moon Europa may conceal an ocean whose chemical signals mimic the patterns of biology, even if life is absent. Each time, our first reaction is to lean toward design, to project intention onto the unknown. It is a deeply human response. With 3I Atlas, the danger is not only in being fooled, but in missing what the deception hides. If we dismiss every strange behavior as natural, we risk overlooking the extraordinary should it one day arrive. But if we lean too far toward the artificial, we risk chasing phantoms, seeing machines where there are only stones. The truth lies in balance, treating every comet as a teacher, every anomaly as both puzzle and possibility. The beauty of deception is that it keeps us alert. A comet that looks ordinary fades into data, forgotten in time. A comet that deceives, that flickers like a message, that breathes in strange chemistry, lives in our imagination long after it is gone. 3I Atlas tricked us, yes, but in doing so, it sharpened our gaze. It reminded us that the universe does not owe us simplicity. So when nature deceives, as it did with 3I Atlas, perhaps it is not failure, but invitation. An invitation to look closer, to question harder, to remember that sometimes the difference between the artificial and the natural is only our own understanding. Today, we call it a comet. Tomorrow, another object may arrive that blurs the line even further. And when it does, the memory of 3I Atlas will remind us how easily the universe can dress its truths in the costume of mystery. The Dark Forest Echo. Could a TLAS be a silent scout? In the quiet of night, when the stars look endless, there is a chilling thought that haunts astronomers and dreamers alike. Perhaps the universe is not empty at all. Perhaps it is full of life, life that hides. This is the essence of the dark forest hypothesis, an unsettling idea borrowed from science fiction but rooted in real cosmic logic. If every civilization is a hunter in a dark forest, then silence is survival. You never shout your presence because you never know who is listening. You hide, you wait, and you watch. Seen through this lens, 3I Atlas takes on a new and eerie shape. To most, it was a comet, faint, fast, strange in its chemistry, vanishing almost as soon as we found it. But to others, its behavior felt like more than coincidence. It slipped into our solar system almost unnoticed, revealed itself only briefly, then disappeared behind the sun at the very moment of its greatest activity. Was that chance? Or was it the quiet passage of a scout slipping through the undergrowth of the galaxy, observing but never announcing itself? The suspicion is not born from paranoia alone. Oumuamua, the first interstellar visitor, already raised the possibility. Its unusual shape, its unexplained acceleration, its silence, all hinted at the artificial, at least enough for scientists to entertain the thought. Then came 3I Atlas, stranger in chemistry, no less fleeting, equally unwilling to linger. Two visitors in quick succession, both behaving oddly. For some, that pattern felt too deliberate, too much like echoes of cautious scouts passing by. Consider how humans scout unknown territory. When explorers once crossed oceans, they did not send their entire fleet to strange shores. They sent a single vessel, quiet and cautious, to observe from the horizon before deciding whether to approach. 3I Atlas could be such a vessel, not crude, not even alive in the way we imagine, but an ancient machine or fragment designed to drift silently, to enter systems and record, to measure whether the inhabitants are advanced enough to notice. Its chemistry, too, plays into the suspicion. The James Webb Space Telescope found an odd dominance of carbon dioxide in its outgassing, unlike most comets we know. Was that natural, or could it be a marker, a signature designed to stand out, to see who would detect it? To a civilization practicing silence, sending scouts with coded chemistry might be safer than broadcasting radio signals. Whoever reads the code is worth watching, whoever does not remains irrelevant. Skeptics, of course, dismiss such ideas as projection. They argue that 3I Atlas's path and behavior can be explained by physics, by chance, by the natural chaos of interstellar debris. And they may be right. But the dark forest hypothesis does not rest on evidence alone. It rests on unease, the sense that silence is too absolute, that emptiness feels too intentional. Every interstellar visitor becomes suspicious not because of what it does, but because of what it might represent, the eyes of a hidden hunter brushing past without a word. There is something haunting about imagining 3I Atlas as a silent scout, not a weapon, not a herald, but a ghost slipping quietly through our skies, indifferent to whether we understand. Perhaps it was watching us as much as we were watching it. Perhaps its tail, flickering strangely in the sunlight, was not just random bursts of gas, but signals, whispers carried into the void, meant for ears, not our own. And if it was a scout, then what happens next? In the dark forest, the first glimpse of a lantern is not a comfort. It is a warning. Someone else is moving among the trees. Someone else knows you are here. If 3I Atlas was such a lantern, then our solar system is no longer hidden. We have been marked, noticed, recorded. What follows may take centuries or longer, but the forest remembers. Or perhaps, the comet was only what science says it was, a fragment of ice and dust thrown into exile by forces we can only guess. Perhaps its strangeness is simply nature's reminder that the universe is larger, older, and more varied than we can imagine. But even then, the echo of the dark forest lingers, because in a universe where silence is survival, every visitor feels like a question, every comet feels like a possibility. 3I Atlas may have been nothing more than dust and gas, but in its fleeting glow, it carried the echo of something darker, the thought that maybe we are not alone, and that those who are out there are not speaking because they know the cost of being heard. Microseeds in the ice, from life-carrying spores to nanotech. 3I Atlas, like every comet, is more than just ice and rock. It is a container, a frozen vault that has carried material across distances we can hardly imagine. When it flared near the sun, releasing plumes of gas and dust, it raised a question that is as old as astronomy itself. What else might be hiding inside? For centuries, thinkers have speculated that comets might carry the building blocks of life. This idea, known as panspermia, suggests that spores, microbes, or at least the essential molecules of biology, could hitch rides inside these icy bodies, protected from radiation by layers of rock and dust. If 3I Atlas predated Earth, if it truly comes from a system older than our Sun, then it may be carrying relics not just of alien chemistry, but of alien biology. Imagine a seed drifting on the wind, caught in a breeze that carries it far from the tree that bore it. Most will fall on stone or sand and die, but some will find soil, some will take root. Comets are like those drifting seeds. Most wander endlessly, lifeless, destined to melt or shatter. But every so often, one collides with a planet that can nurture what it carries. Earth itself may have been seeded this way, its first spark of life ignited by molecules carried on comets. Could 3I Atlas, then, be a microseed from another world? The protection it offers is real. Deep within the nucleus of a comet, beneath layers of frozen gas, temperatures remain low and radiation is blocked. In experiments on Earth and aboard the International Space Station, spores and bacteria have survived extreme cold, vacuum, and even bursts of cosmic radiation. If life can endure such conditions here, why not elsewhere? A microscopic hitchhiker could, in theory, sleep for billions of years, awakened only when its vessel encounters the warmth of a new star. But panspermia is only one layer of speculation. In recent years, a stranger possibility has emerged. What if the microseeds inside comets are not biological at all, but technological? Imagine a civilization advanced enough to engineer self-replicating nanomachines, smaller than dust grains, capable of surviving radiation, repairing themselves, and carrying instructions across interstellar space. Such machines could spread like dandelion fluff, riding comets as vehicles. While spores would be fragile, nanotech could endure indefinitely, hiding in the ice until conditions were right to awaken. If that sounds like science fiction, consider this. Humanity itself has already begun designing probes small enough to ride on beams of light. Tiny spacecraft the size of chips, meant to sail beyond our solar system. If we, a young species, can dream of this, what might older civilizations already have done? A comet like 3I Atlas, passing silently through a planetary system, could be the perfect courier, carrying seeds not of life, but of machines. And yet, this duality, life or machine, blurs at the edges. If a civilization were to design nanotech seeds, they might mimic biology. Perhaps spores are machines, engineered to look natural. Perhaps life itself, everywhere it arises, is not spontaneous but planted, part of a cosmic experiment too vast for us to see. 3I Atlas, with its strange chemistry and mysterious glow, becomes a candidate for such speculation. A frozen ark bearing instructions, waiting for worlds like ours to decode them. Of course, scientists remain cautious. No evidence of microbes or nanotech has ever been found in comets. Only complex organic molecules, amino acids, carbon chains, the ingredients of life but not life itself. Still, that in itself is extraordinary. The Rosetta mission, which studied Comet 67P in our own solar system, detected glycine, a fundamental amino acid. If such molecules form naturally here, why not in other systems? 3I Atlas, then, may be carrying a different recipe. Alien organics, stranger than ours, waiting to be released. Even if there are no spores, no machines, the idea of microseeds lingers because it resonates with something familiar. We understand seeds. We understand the fragility of a grain that contains within it the promise of a forest. To imagine 3I Atlas as a drifting seed is to see it not only as a visitor, but as a messenger, carrying in its frozen heart the potential for growth, or at least the memory of what once was. As it fades into the dark, we are left with questions. Did its tail scatter alien molecules across our solar system? Tiny fragments that will one day fall to Earth unnoticed, blending with our air and oceans. Did we already breathe in its dust without knowing? Are we, in some quiet way, already touched by what it carried? 3I Atlas may be only ice and dust, but in the imagination it is more, a seed adrift in the galaxy, carrying life or machines or the possibility of both. Whether natural or artificial, its silence does not erase its potential. It reminds us that the universe is not just vast in distance, but in intention, that even a grain of dust can hold within it the story of a world we will never see. The absence of signal, why its silence may be deliberate. When 3I Atlas streaked through the solar system, one of the first questions people asked was the most human of all. Is it trying to say something? Telescopes were turned not only to its light, but to the quiet between. Radio dishes listened, scanning across frequencies, waiting for even the faintest artificial hum. What they heard was nothing. Silence. For most scientists, this was no surprise. A comet is, after all, only ice and dust, but for others, the silence was more unsettling than any signal could have been, because sometimes silence itself feels deliberate. The universe is vast, ancient, and noisy in its own way. Pulsars beat like celestial metronomes. Quasars scream across billions of light years. Even comets, when they pass close to Earth, can scatter radio noise through the plasma of their tails. Yet 3I Atlas, with all its strangeness, the hyperbolic orbit, the bizarre chemistry, the flickering tail, spoke not a word. For some, this quietness carried the eerie weight of choice. If it had been artificial, perhaps its silence was not absence, but strategy. Here is where the dark forest hypothesis re-enters the story. In a galaxy where survival favors the cautious, any intelligent civilization might choose silence over broadcast. Sending signals is like lighting a fire in a dark wood. You illuminate yourself, but you also reveal your position to anything watching. If 3I Atlas were a scout, or even a relic of one, then silence would not be a flaw. It would be its most important feature. Consider how humans behave when exploring. Soldiers on reconnaissance do not shout. Submarines do not announce their position with horns. Even hikers, deep in wilderness where predators might lurk, instinctively tread quietly. Perhaps 3I Atlas was no different. A silent observer passing through quickly, listening, watching, gathering, but never calling attention to itself. Its silence could be the very thing that kept it safe for billions of years. Even in natural terms, silence has meaning. A comet from our solar system would usually advertise its presence, its tail blazing with water vapor, its radio emissions scattering as charged particles streamed away. 3I Atlas was not like that. Its unusual chemistry meant that its signals, if any existed, were weaker, harder to detect, hidden in the noise of space. Was this simply an accident of its makeup, or the clever disguise of something designed to blend in? The absence of signal also strikes a psychological chord in us. Humans crave communication. We write messages in bottles, launch plaques aboard spacecraft, beam radio transmissions toward stars. When we see a visitor from another system, we expect it to speak, to reveal itself, to confirm our hope that we are not alone. 3i Atlas did not. It left us with silence, and silence is often the hardest answer to accept. But perhaps silence is its own kind of language. Think of a paused breath before a word is spoken, of a gaze that lingers without explanation, of a door left open but never crossed. The lack of a signal does not always mean there is nothing to say. Sometimes it means the message is not meant for us, or not meant to be understood in the way we expect. A signal can be hidden in chemistry, in dust trails, in orbits themselves. A signal can be in the act of passing quietly, a reminder that not all presences are meant to be loud. Of course, the simplest explanation is that 3i Atlas truly was silent because it was natural, an ordinary comet, however strange in detail, carrying no hidden agenda. And yet, its silence still resonates, because in it we hear our own longing, our own fear, our own awareness that maybe the universe is not silent at all, only that the voices we hope for are speaking in ways we cannot yet hear. 3i Atlas has already gone, fading back into the endless dark. It left behind no transmissions, no beacons, no reply to our listening. But in that absence lies the most haunting possibility of all, that the silence was not emptiness but intention, that the galaxy is alive with watchers, each one choosing quiet over risk, each one passing through like shadows in the trees. And we, here on our small blue world, are left to wonder whether silence is the answer we fear, or the one that keeps us safe. Machines that outlast suns. If ATLAS is a construct, who built it? When astronomers first measured the faint glow of 3i Atlas, most assumed it was a natural body, a comet ejected from some forgotten star system, wandering the galaxy until chance carried it into our view. And yet there lingers another possibility, one that whispers in the spaces between what we know and what we only imagine. What if 3i Atlas is not natural at all? What if it is a construct, a machine designed not for decades or centuries, but for lifespans measured in billions of years? If so, the question follows swiftly: who could have built it? The thought stretches the imagination, but not beyond possibility. On Earth, humanity has already begun dreaming of machines meant to outlast us. Spacecraft like Voyager, still humming faintly, decades after launch, already drifting toward interstellar space. These tiny emissaries carry golden records, messages engraved in metal meant to endure long after our languages fade. If we, a young species barely learning to leave its cradle, can imagine building such things, then what might a civilization millions of years older have accomplished? 3i Atlas, if artificial, would not be a fragile probe like ours. It would need to be something else entirely, a construct capable of enduring cosmic collisions, surviving radiation storms, and wandering the void without power for unimaginable stretches of time. Perhaps it would be layered in protective crust, indistinguishable from a comet on the outside. Perhaps its core would be machine, insulated beneath miles of ice, using the comet's body as armor. In this way, it would masquerade as ordinary debris, drifting unseen until it encountered a world worth observing. The builders of such a machine would need patience beyond human comprehension. Imagine investing in a craft that may not reach another star for 100 million years. Imagine designing something not for your children or grandchildren, but for beings who may live in a galaxy utterly transformed. That is the hallmark of an ancient civilization, thinking in spans of time where suns themselves are temporary. If 3i Atlas is such a construct, then its creators were not merely advanced, they were timeless. But who were they? One possibility is that they were like us, only far older, born on a rocky world circling a now dead star. Perhaps they, too, looked up at their skies and asked whether they were alone. Perhaps they built emissaries like we build spacecraft, but with knowledge and resources that allowed them to last until long after their own world was gone. In this version, 3i Atlas is not a scout for conquest, but a drifting bottle, a relic of a civilization that vanished before Earth was even born. Another possibility is darker. Perhaps its builders are not gone, but hidden, watchers in the dark forest, sending out machines disguised as comets to monitor without revealing themselves. To build such machines would require not only technology, but intent. The intent to remain unseen, to let their constructs pass as natural while they quietly catalogue the galaxy. If 3i Atlas is one of these, then it is part of an invisible web, a surveillance net stretching across the stars. And yet, there is also the thought that chills most deeply. What if its builders never intended it for us at all? What if 3i Atlas has been wandering for eons, built for reasons we could not even guess, measuring phenomena we cannot yet name, carrying instructions that were never meant for human eyes? To encounter it is like stumbling across a tool left in the woods, rusted, ancient, its function mysterious. You know it was made by someone, but you do not know who or why. The very idea of a machine that can outlast suns forces us to confront our own fragility. Our buildings crumble in centuries. Our civilizations rise and fall in millennia. Even Earth itself has an expiration date, destined to be consumed when the sun swells into a red giant. But 3i Atlas, if it is truly a construct, has already outlasted countless worlds. It may continue long after ours has faded into memory, carrying in its silent shell the fingerprints of beings we will never know. Perhaps that is its true lesson. Whether natural or artificial, 3i Atlas is a reminder that the universe is not measured in human spans. It is measured in the lifespans of stars, in the journeys of objects that wander for billions of years. If it is a machine, then it is one that reflects not only the genius of its builders, but their perspective, a patience as vast as the galaxy itself. And so, the question lingers like a shadow. If 3i Atlas is a construct, who built it? Were they dreamers like us, casting bottles into the cosmic sea? Were they predators, cloaking their watchers as harmless ice? Or were they something stranger still? Beings for whom the survival of suns was only a starting point, not a limit. The comet passed, silent and indifferent, leaving no answers. But in its silence, it carried the weight of possibility, that somewhere, long ago, hands not unlike ours shaped it, and that it still drifts on, carrying their story through the endless dark. Galactic Archaeology, treating 3i Atlas as a relic. To look at 3i Atlas is to look not only at an object, but at a fragment of history, a history so vast it makes the rise and fall of civilizations seem like the blink of an eye. Astronomers often call comets time capsules, but in the case of 3i Atlas, that phrase feels far too small. This is not just a capsule of one system's past. It may be a relic of the galaxy itself, a shard from an age older than our sun. This is the essence of galactic archaeology, the attempt to study interstellar wanderers as if they were fossils, not just ice and rock. Just as archaeologists on Earth sift through the remains of ancient cities to piece together lost cultures, astronomers can sift through the chemistry and structure of objects like 3i Atlas to reconstruct stories of long-dead stars and forgotten systems. Think of it this way: every grain of dust within 3i Atlas carries a signature. Some may have been forged in the heart of a star that lived and died before the sun was born. Others may come from the icy outskirts of a planetary system destroyed by gravitational chaos. Its carbon dioxide-heavy composition may not be random, but the echo of a different kind of star nursery, one with conditions unlike those that formed Earth. In this way, the comet is not only a visitor, it is a record. On Earth, archaeology often begins with fragments, a broken pot, a chipped tool, a faint carving. From these, entire civilizations are reconstructed. 3I Atlas is a similar fragment, chipped from a cosmic story we cannot fully see. Its orbit tells us it was thrown violently from its home. Its chemistry tells us it formed under alien conditions. Its survival tells us it has drifted for billions of years. Together, these clues form a narrative, not of a culture, but of a galaxy forever in motion, where creation and destruction weave endlessly together. There is humility in this perspective. Human history is measured in thousands of years, but galactic archaeology measures in billions. Imagine digging in your backyard and finding not just an arrowhead or a coin, but a stone carved by hands 100 million years ago. That is the scale at which 3I Atlas speaks. We cannot trace the faces of its makers, if it even had makers, but we can sense the depth of time it carries, like a whisper from an age long gone. Some have even suggested that galactic archaeology could reveal not just natural history, but cultural. If civilizations older than ours once seeded comets with signatures, deliberate chemical ratios, embedded isotopes, or structures hidden beneath ice, then objects like 3I Atlas could be more than relics. They could be artifacts. To study them is to brush the dust from a cosmic monument, to wonder whether we are seeing design or chance, and to accept that sometimes the line between the two is nearly invisible. Even if it is entirely natural, 3I Atlas holds value as a relic. It may preserve the chemistry of an earlier Milky Way, from a time when star formation was more violent, when heavy elements were scarcer, when conditions shaped bodies unlike anything our solar system produced. Just as archaeologists on Earth read bones to learn of ancient climates, astronomers read interstellar comets to learn of galactic eras. 3I Atlas is not just a comet, it is a fossilized page from the Milky Way's earliest chapters. There is also something deeply human in treating it this way. Archaeology is about stories, connecting to those who came before, piecing together lives we cannot see. Galactic archaeology does the same, but on a scale so large it makes us feel like children in a museum, gazing at relics too vast to comprehend. 3I Atlas becomes a bridge, linking us not to our ancestors, but to ancestors of the stars themselves. And perhaps, like all relics, its true value is not in the object itself, but in what it awakens in us. To see 3I Atlas as a relic is to admit that we are not at the center of the story. We are latecomers, arriving after most of the play has already been performed. The galaxy has been busy for billions of years, scattering its artifacts across space, waiting for us to notice. 3I Atlas is gone now, fading into the dark, but in its passing, it left behind more than data. It left behind the sense that archaeology is not confined to Earth or even to planets. It extends into the galaxy itself, where relics like this comet wander, silent and ancient, waiting for us to uncover their meaning. To treat 3I Atlas as a relic is to see it not as an intruder, but as a gift, a shard of history that drifted into our skies, giving us, for a moment, the chance to hold in our instruments the memory of worlds long vanished. A needle among stars, how rare such discoveries truly are. When astronomers first confirmed the trajectory of 3I Atlas, they knew instantly what it meant. This was not just another comet, not another icy body from the far edges of our solar system. Its orbit was hyperbolic, too open to ever return. It had come from elsewhere, from beyond the sun's reach, and that made it part of an incredibly rare class of objects, true interstellar visitors. To grasp just how rare, imagine the night sky above you. Every pinpoint of light represents a star, each surrounded by its own family of planets, asteroids and comets. Across the galaxy, trillions of comets are born, countless fragments of ice and dust circling their suns. Some are nudged outward by gravitational tugs, flung into the dark, set adrift between the stars. These are the wanderers, the interstellar debris. But space is vast, so vast that even with uncountable numbers adrift, the chances of one crossing our tiny solar system are astronomically low. It is like tossing a single grain of sand into the ocean and waiting for it to drift ashore on your beach, or like walking into a desert, dropping a single coin and expecting someone on the far side of the world to stumble upon it centuries later. The distances are too great, the odds too small. And yet, in just a few years, we have seen not one but several. Oumuamua in 2017, Borisov in 2019, and now 3I Atlas. Each discovery was a reminder that even the rarest events can sometimes come in clusters, like raindrops hitting the same patch of stone. But their rarity makes them precious. Astronomers speak of them the way archaeologists speak of chance finds: the intact tomb discovered by accident, the fossil revealed when a hillside erodes. Most comets we study are local, their chemistry familiar, their orbits predictable. An interstellar comet, by contrast, is a window into another system, another history, another way of being. Each one carries within it the story of stars we will never reach, planets we will never see, and eras that ended before Earth itself began. 3I Atlas, then, was a needle found in the cosmic haystack. And like all such discoveries, it raises an unsettling question. If the universe is filled with wanderers, how many pass by unseen? We only detected 3I Atlas because of modern surveys, telescopes scanning the skies with relentless precision. A century ago, it would have slipped past unnoticed. A millennium ago, it might have flared above our ancestors without them ever realizing what they were seeing. For every interstellar visitor we detect, perhaps hundreds drift by, faint and silent, never caught by our gaze. This rarity fuels both wonder and unease. On one hand, it means that every detection is a treasure, a once-in-a-lifetime chance to study something truly alien. On the other hand, it reminds us of how little we know. We may be surrounded by wanderers, messengers from distant systems, and yet our instruments catch only a fraction. How many relics of other stars lie just beyond our vision, waiting? How many silent scouts, if such things exist, have passed unnoticed because we were not watching? The metaphor of a needle is apt in another way. A needle is not only rare, it can also prick. Finding one among hay is not just unlikely, but potentially dangerous. Interstellar comets are the same. Their rarity makes them mysterious, and their mystery makes us uneasy. Are they harmless debris or something more? Are they gifts of knowledge or warnings drifting across space? With so few examples, we cannot yet know, and so each discovery takes on outsized meaning. Oumuamua taught us that not everything follows cometary rules. Borisov showed us what a truly alien comet looks like: icy, active, and undeniably interstellar. 3I Atlas brought new puzzles, from its strange chemistry to its vanishing act. Together they form not a pattern, but a hint, the first threads of a tapestry we are only beginning to glimpse. To find a needle among stars is to realize that the galaxy is more connected than we thought. Our solar system is not an isolated island. It is a beach on which driftwood sometimes lands, carrying stories from faraway shores. We may never know who shaped 3I Atlas or what forces flung it into exile, but in spotting it at all, we are reminded of how rare, how fragile, and how extraordinary such encounters are. Most nights, the sky is steady, the stars unchanging, but every so often, a faint light moves where none should be. And in those moments, we catch sight of the needles, rare, fleeting, precious, threads binding us, however briefly, to the rest of the galaxy. Beyond Voyager's reach, why no probe could catch it. When 3I Atlas first appeared, some wondered if we could send a spacecraft to meet it. After all, humanity has already launched machines beyond the orbit of Pluto. Voyager 1, the most distant human-made object, has been traveling for nearly half a century, crossing more than 14 billion miles from Earth. Could we not simply turn one of our probes toward this new interstellar wanderer to chase it down and see what secrets it carried? The answer, humbling as it is, was no. 3I Atlas was already far beyond our reach. The problem begins with speed. 3I Atlas entered the solar system moving faster than any spacecraft we have ever built. Tens of kilometers per second, faster than a bullet, faster even than Oumuamua before it. By the time astronomers confirmed its trajectory, it was already racing outward on a one-way path into the dark. To catch it, we would have needed to launch a probe not in years, but in weeks, something our technology, planning, and infrastructure could never allow. Even if we had launched at once, no current rocket could have caught up. Voyager 1, which rides the fastest escape trajectory we've ever achieved, crawls compared to the speed of 3I Atlas. New Horizons, the probe that flew past Pluto, moves faster still, but even it would fall hopelessly behind. It is like standing on a train platform watching a freight train thunder past at full speed. No matter how quickly you start running, you cannot hope to match its momentum once it's gone. This limitation forces us to face an uncomfortable truth. Humanity is still tied to its cradle. Our probes are tiny sparks compared to the roaring motions of the cosmos. They drift outward, yes, but at a pace that pales beside interstellar visitors. For now, we are watchers, not pursuers. We can glimpse, we can measure, but we cannot catch. The irony is sharp. For decades, Voyager has carried messages for hypothetical alien finders, a golden record etched with greetings, music, and diagrams of our world. We hoped it might someday be found by another civilization. And yet, when another world's debris passes through our skies, we cannot even reach it. Our emissaries crawl outward, while theirs, if 3I Atlas is indeed a kind of emissary, fly past uncatchable, vanishing into the black. But this is not only a story of limitation, it is also a story of preparation. Scientists know that 3I Atlas will not be the last. Interstellar visitors are rare, but they come. The key is not to chase them after they arrive, but to wait with readiness. Concepts already exist for spacecraft that could remain on standby like cosmic lifeboats, ready to launch at a moment's notice. One such idea is called the Comet Interceptor, a European Space Agency mission designed to wait in deep space until a target passes close. It will not catch 3I Atlas, but perhaps it will catch the next. And yet, there is something poetic in our inability to follow. It reminds us of the vastness of scale, the gulf between our efforts and the motions of the galaxy. Voyager, once the pinnacle of speed and endurance, is still just a child's first step into the dark. 3I Atlas, by contrast, is a veteran traveler, a survivor of collisions and radiation, a wanderer older than Earth itself. One is the product of a young civilization daring to stretch its fingers outward. The other is the embodiment of cosmic time, moving on a trajectory no machine of ours could match. If we had been able to catch it, perhaps we would have cracked open its chemistry, sifted its dust, and asked whether it carried seeds of other worlds. But perhaps it is better this way. Some mysteries are meant only to be glimpsed, their passage a reminder of how far we still have to go. And so, beyond Voyager's reach, 3I Atlas drifts on. We could not catch it, but in watching it slip away, we learned something just as valuable, that we are at the beginning of our story, not the middle. That the galaxy is full of travelers, and one day, when our machines are faster and our patience longer, we will be ready not just to watch them pass, but to meet them in the dark. The Fragile Mirror, how a TLAS reflects our own impermanence. When astronomers turned their instruments toward 3I Atlas, they saw more than just a comet. They saw a mirror, not one of polished glass, but of ancient ice and dust, reflecting something about ourselves that is difficult to confront: our fragility. In its silence, its strangeness, its fleeting passage, 3I Atlas became less a traveler and more a reminder of impermanence. Think of what it represents. Here is an object born long before Earth was formed, older than our oceans, older than the continents, older even than the sun. For billions of years, it has wandered the galaxy, surviving collisions, radiation, and isolation. And yet, it is delicate, so delicate that a single close encounter with a star could shatter it, that a small nudge could alter its course forever. This paradox, ancient endurance paired with profound fragility, feels hauntingly familiar. For humanity, too, is both enduring and precarious. Our species has survived ice ages, plagues and wars. Civilizations have risen and fallen, yet the thread of human life continues. But set that thread against the backdrop of cosmic time, and it is a fragile line indeed. We have existed for only a moment compared to the age of 3I Atlas. Our great monuments, our histories, our technologies, these are sparks, brief flares in the darkness, as transient as the flicker of the comet's tail. The mirror deepens when you consider its path. 3I Atlas does not circle back, does not linger. It entered our solar system briefly and is gone forever, leaving behind only traces of light and dust. So too, one day, will we. Earth itself is not permanent. In a few billion years, the sun will swell into a red giant, consuming or scorching our planet. Long before then, shifting climates, impacts, or our own mistakes could undo much of what we have built. Like the comet, we are wanderers in time, here for only a brief passage. This realization can be unsettling, but it can also be strangely comforting. Fragility gives meaning. A flower is beautiful, not despite its short life, but because of it. A sunset captivates us precisely because it fades. 3I Atlas, streaking briefly through our skies, was meaningful because it would never return. In its impermanence, it mirrors us and reminds us to treasure our own fleeting moments. Even its chemistry feels like metaphor. The James Webb Space Telescope revealed its strange dominance of carbon dioxide, so different from comets we know. Its breath was alien, its patterns unfamiliar. And yet, when it outgassed near the sun, it was doing the same thing our comets do, exhaling, leaving trails of itself behind. Is that not what humans do as well? Across history, across generations, we leave fragments of ourselves, songs, stories, cities, knowing they too will erode, knowing they too are fragile trails in the larger arc of time. The fragility of 3I Atlas also speaks to our hunger for permanence. We long for answers, for meaning, for certainty, but when it came, it offered only mysteries, refusing to give us closure before it slipped away. In this, it mirrors the human condition, our search for truth in a universe that rarely offers full explanations. Perhaps that is why it lingers in imagination, not because of what we learned, but because of what it withheld. And so, the comet becomes a kind of teacher, not of astrophysics alone, but of perspective. It reminds us that survival does not mean invincibility, that endurance does not mean permanence. It reflects back to us the reality that we too are fragile travelers, brief flashes of light in an ancient and indifferent galaxy. But fragility is not weakness. It is the space where meaning grows. The fact that we are temporary does not diminish us. It elevates our moments, our choices, our stories. 3I Atlas drifts on, its fragile body carrying the memory of worlds long gone. We, in turn, carry the memory of it, adding its fleeting glow to our own fragile history. In this way, 3I Atlas is not just a mirror of impermanence, it is also a reminder of beauty, that even the briefest visitors can change how we see ourselves, leaving us with the knowledge that fragility, far from being something to fear, is the very thing that makes life luminous. The door, it leaves open, awaiting the next messenger. When Three-Eye Atlas slipped beyond the sun's light and out of our reach, it did not close the story, it opened one. Its fading glow left behind not an ending, but a doorway, a quiet space filled with anticipation. Because if Three-Eye Atlas has taught us anything, it is that the galaxy does not send just one messenger. It sends many, scattered across time, drifting toward us like notes in a song we have only just begun to hear. The feeling is like watching a stranger walk past your window at night. They do not knock, they do not speak, they do not even look your way. And yet, their passing reminds you that others are out there, moving in the dark. Three-Eye Atlas was such a stranger, silent, fleeting, but proof that we are not as isolated as we once believed. Its exit leaves us waiting, wondering when the next figure will pass through the cosmic street outside our door. This waiting carries both excitement and unease. On one hand, each new interstellar visitor is a scientific gift, a chance to study materials from stars we may never reach. Oumuamua gave us the first taste. Borisov showed us the unmistakable chemistry of another system. Three-Eye Atlas added strangeness, with its unusual balance of gases and its elusive nature. Each messenger has brought something different, as if the galaxy were offering glimpses of its vast library, one book at a time. What will the next bring? A comet richer in organics than any we have seen, a fragment of a shattered planet, or something that refuses to fit into our categories at all? On the other hand, the waiting can feel ominous. The dark forest hypothesis lingers like a shadow. What if these messengers are not just debris, but scouts? What if their silence is deliberate? If that is true, then the door left open by Three-Eye Atlas is not simply an invitation to learn. It is also a reminder that someone, or something, may already be aware of us. And if so, what will they decide when the time comes not to send fragments, but something more deliberate? Yet perhaps the door is not theirs, but ours. Three-Eye Atlas has gone, but in its wake, NASA and other space agencies have been spurred to design missions ready to intercept the next. The Comet Interceptor will wait in space, like a sentinel, prepared to launch toward a passing stranger. Others dream of faster spacecraft, light sail probes, and even missions that could one day chase down an object beyond our solar system. In this sense, the door left open by Three-Eye Atlas is one of opportunity, an invitation for humanity to step forward, to prepare, to meet the galaxy halfway. And there is something more intimate too. The comet's passage stirred the imagination of millions, not just scientists. It became a story told in headlines, in whispers, in late-night wonderings. Was it only ice and dust? Was it more? Did it notice us as we noticed it? The door it left open is also the door of imagination, through which countless people now look at the night sky differently, asking questions they had never asked before. If you step outside on a clear night and let your eyes wander upward, you may feel this door yourself. The stars look steady, eternal, but somewhere out there, another wanderer is already on its way. It may take decades, centuries, even millennia to arrive, but it is coming. A messenger carrying with it the chemistry, the history, and perhaps the mysteries of another system. We do not know when or where it will appear, only that it will, and when it does, the memory of Three-Eye Atlas will shape how we greet it. The comet left us no answers, no signals, no certainty, but it left us something perhaps just as powerful, the sense of continuity, the knowledge that the story is not over, that the door to the galaxy is ajar, and through it more visitors will pass. Three-Eye Atlas is gone now, slipping into the dark. But the space it opened remains, a door, invisible yet undeniable, through which we wait for the next messenger to arrive, carrying, as this one did, the strange and silent reminder that we are not alone in the forest of stars.